All right, let's talk about something you see literally every day. A box. It sounds simple, right? But inside this basic shape is some seriously cool geometry. It's not just a container, it's kind of the key to understanding the 3D world all around us.
Okay, be honest. Have you ever been wrapping a gift and ended up with way too much paper? Or tried to stuff something into a box that looked like it should fit but just wouldn't? Yeah, we've all been there. And believe it or not, that frustration, that's actually a geometry problem. And the solution comes down to two super important ideas: surface area and volume. Stick with me, and I promise you're going to be a pro at this stuff by the end of this. So here's our game plan. We're going to kick things off with that perfect box problem. Then, we'll figure out how to measure the outside of a shape and then how to calculate what's on the inside. After that, we'll get into why cubes are so special and even solve some trickier shapes. And to wrap it all up, we'll see how all this math shows up in your world, like all the time. Sound good? Let's do it.
All right, first up, let's talk about the outside of the box. This is what we call its surface area. Think back to that gift wrapping scenario. The absolute minimum amount of paper you'd need to cover the entire gift with no overlaps, that's the surface area. It's basically like we're measuring the object's skin. And here's a really cool way to picture it. Imagine you've got a regular old cardboard box. Now, what if you could just slice it along the edges and lay it out completely flat, like a big cross-shaped piece of cardboard? The area of that flat piece, well, that's your surface area. It's literally just the total area of all the faces added together.
Now, the great thing here is that you've got options for how to figure this out. Method 1 is the most direct. Just find the area of all 6 faces, front, back, top, bottom, left, right, and add them all up. Easy enough. Or you could use a shortcut. Since the front and back are the same, the top and bottom are the same, and the sides are the same, you can just find the area of the 3 unique faces and multiply that by 2. And there's even a third way, the base plus sides method. Let's actually see these in action with a real example.
Okay, check this out. Let's say we have a little box that's 3 centimeters by 2 centimeters by 1 centimeter. Look what happens. It doesn't matter which of the 3 methods we use. Whether we add up all 6 faces, use the shortcut, or do the base plus sides thing, boom. We get the exact same answer every single time, 22 square centimeters. So really, it's just about picking whichever method makes the most sense to you. All right, so we've totally nailed the outside of the box. Now it's time to see what's going on inside. We're shifting gears from surface area to volume. And volume is all about how much space something actually takes up.
So, if surface area is about flat 2D space, volume is all about 3D space, which means we need a 3D unit to measure it. And that's where this little guy comes in, the cubic centimeter. Just picture a tiny little sugar cube that's exactly 1 centimeter on every side. The volume of any object is really just a question of how many of these tiny cubes can you pack inside it. Now, obviously counting millions of tiny imaginary cubes one by one would be, well, a total nightmare. Thankfully, there's a super simple formula. It all starts at the bottom with the base of the box. When you find the area of that base, just length times width, what you're really doing is figuring out how many of our little 1 centimeter cubes can fit in a single flat layer on the bottom.
And once you know how many cubes are in that first layer, the rest is easy. You just multiply by the height. I like to think of it like stacking layers of Lego bricks, or even pancakes. The base area is your first pancake. The height just tells you how many pancakes you need to stack to fill up the whole box. See? Super simple when you think about it that way.
Okay, look at this number, 1 million. What on earth could that possibly have to do with boxes and volume? It's a huge number, right?
Get this. That is how many of those tiny 1 centimeter cubes can fit inside a single box that's just 1 meter tall, 1 meter wide, and 1 meter long. Just one. Because a meter is 100 centimeters, you're calculating 100 times 100 times 100, which is a million. It's just a crazy, mind-blowing example of how quickly volume can scale up.
Okay, now that our brains have recovered from that 1 million cube thing, let's simplify things a little. Let's focus on a very special type of box, the perfect cube. This is where the math gets really elegant and simple.
You see, with a regular box, a rectangular prism, you're juggling 3 different numbers, length, width, and height. But a cube, all the sides are the exact same length, and that makes the formulas so much cleaner. The surface area? Just find the area of one face and multiply it by 6, because they're all the same. The volume is just the side length times itself again, or side cubed. I mean, it really doesn't get any simpler than that.
Okay, you've got the basics down solid. So, time for a little challenge, a next-level problem, if you will. We're going to look at a more complex shape, but don't sweat it. You literally have all the tools you need to solve this thing already.
So take a look at this L-shaped block. It's obviously not a simple box, right? But if you look closely, it's made of simple boxes put together. And it turns out there are two really clever ways we can figure out its volume.
Okay, method one is what I call the addition method. You just imagine taking a knife and slicing this L shape into two smaller, regular boxes. Then you find the volume of the first box, find the volume of the second box, and just add them together. Simple as that. And for this one, it comes out to 1,995 cubic centimeters.
Now, the second method is a little more creative. This is the subtraction method. This time, imagine you start with one big, solid block. Then you take a chunk out of it. You carve away a smaller box to leave the L shape behind. So all you have to do is calculate the volume of the big block you started with, then subtract the volume of the little piece you removed. And guess what? You get the exact same answer, 1,995 cubic centimeters. Pretty cool, right?
So we've played around with a bunch of shapes and numbers, which is cool, but I know what you might be thinking. When am I ever actually going to use this stuff? Well, the answer is probably a lot more than you think. Let's talk about where this stuff shows up in the real world.
I mean, just think about it. The architecture of the building you're in right now, that started with surface area and volume. That shipping box that just arrived at your door, its design and how it fits in the truck is all about this stuff. Heck, even the graphics in your favorite video games are built using these exact same principles. It's kind of like the hidden language of the physical and even virtual world.
And here's the most important takeaway. The crucial point isn't just about memorizing formulas, right? It's about understanding these two big ideas, surface area and volume. Because once you get them, you really do have the power to describe and even build the world around you.
So, before we wrap this up, I want to leave you with a question to chew on. Nature loves efficiency. So with that in mind, what shape in the natural world do you think holds the most volume with the least amount of surface area? Think about it. The answer is probably all around you. Thanks for diving into this with me.